want to do Hess's law.
I don't think I've ever seen this room with that.
It's better, isn't
It is. It feels more open.
People from chemistry, what is Hess's law?
I got you.
System of equations define delta H.
The delta-
Excellent. And they are standard. That's what it is. So the formal definition is that mathematical operations performed on chemical reactions are the same when applied to the heat of reaction. So what Hess's law allows you to do is to find delta H0 for many reactions, and then use those to calculate delta H's for other reactions. And the other reactions could be completely different reactions. So it's actually very useful. And I'll do an example. Okay, and before I do that, I have to define what delta H is. So delta H is defined as, for chemical thermodynamics, as the heat produced when the number of moles specified in the balanced equation. I want you to underline the word balanced equation. Casey, what does that mean?
Like both sides of the equation are equal, so like if you have the two, like, I guess halves of the equation, you have to balance out the amount of elements.
Exactly. So that basically means is we have to balance equations before we begin. I will not. Not in this case. Okay. So, okay. The last thing I want to do today, before we stop, is just this formation reaction. Can I talk about what is a formation reaction? O2 goes to O2. What do you think delta HF will be?
Zero. Depends on their state.
The gas to gas.
Zero.
Done. So if they are in a standard state, beginning and end, delta F will be zero.
So are we even in the standard state of certain chemicals?
So for example, if I give you this reaction, the methane one, right? So we're still gonna use this. Can I just copy it? You have to rewrite it. I'll copy it. I'll be lazy. Copy. So I'm gonna use my this reaction again for non-chemistry people. These are called,
Get it red.
I made it red. These are called reactants, and these are called, and how did we balance these? 5 O2, 3 carbon dioxide, and 4 oxygens. I need to find the delta H total for this. I don't know that. But suppose, you knew delta H's for certain other things. So for example, I knew from a textbook somewhere that propane C in the solid state plus H2 in the gas state goes to propane. It is a creation reaction with certain constants, 3, 4, and 1. And that gives me a delta HF formation of 0. The value for this reaction is negative 103.8 kilojoules per mole. Suppose I knew that. And I have another textbook that tells me that, well, that one I did before, but the formation of oxygen is O2 goes to O2, both gases. The formation reaction is the delta H is 0. Now for carbon dioxide, I know carbon in the solid state plus O2 in the gas state gives me carbon dioxide in the gas state. And I know it is 1393.5 kilojoules per mole. And say for water, H2 in the gas state plus O2 in the gas state gives me H2O in the gas state with a 2 and a 2. And my answer comes out that it is negative 214.8 kilojoules per mole. If I know all of that, can I find the delta H for this reaction? How? So Hess's law said delta HF0 of the reaction that I am looking for is equal to the sum of the delta H's of the product minus the sum of the delta H's of the reactants at 0 state. Okay. So how do we do this? The products on one side.
So you can kill it.
Okay. So this will be how many? This one and that one, and this one and that one. So delta H of the product will be 3 times the carbon dioxide number minus 393.5 plus 4 times the oxygen number, negative 241.8, minus 1 times negative 103.8 plus 5 times oxygen, right, which was 0. Did I do that right?
Yes.
Okay. And magic happens, and I come up with negative 2251.5 kilojoules.
2,000.
Can someone check my math?
The book has negative 2,043.9.
What is it?
Negative 2,043.9.
Someone's fix this. Because apparently we're getting them different numbers.
Yeah, that's right.
Which one is right?
Oh.
The book is right? I'm wrong. Wait, what's the answer then?
2043.9.
Hold on. What is it?
2043.9.
2043.9. Thank you for confirming. I had it wrong here.